All right. Let's continue with our series of tutorials on Python, and we're gonna look at exceptions and several other concepts, which are gonna wrap up our discussion for my part, and my colleague Mkwazu will take it from there. So we started with looking at recursive. At exceptions. And exceptions are just like in any other programming language, are meant to handle errors in the program. For example, you have a piece of script that does something, and whenever there is an error, it doesn't know what to do. For instance, let's take an age of a person, and we are getting it from the user. Let me put it this way. We want to input age of a person, so we ask age, right? So the person can specify age, and we want to put it into a variable age, but we want to convert it straight. We don't want to, we don't want to leave it as a string. So we can say int something like that, and I want to print age, right? In fact, this program has nothing wrong. If you run it, it will ask for your age. Let's say 45, and if you print, that is 45. Now, our expectation whenever we are writing this program, when we were writing this script, our expectation was that the age should be an integer or a number, right? Now, what if someone is crazy and comes up with a word, right? What if someone comes up or inserts or inputs a word or an alphanumeric or whatever? So let's try to run it. Oh, let me write it in a new cell. Let me copy this and put it here. Let me run it. And now instead of 45, I write TR or anything, right? If I run that, I'm absolutely going to end up in an error. I don't know if you can see the error, but you can see here it is just loading all this time, right? We need to break it. And that error is normally a value error, right? So let me just close it, or let me just stop executing it. And you can see there's an error after I've interrupted it. Anyway, I've interrupted it. So it was going to end, it was going to run almost endlessly. So you need to find a way to tap the errors and make sure they are not affecting the flow of your program. So you can cut this and put a try and except. For some of the languages, I'm sure you have come up with this try except. So you have try, and then you put except value error, because we are dealing with a value error, right? So, and what is our value error? We just print any message, okay? That at least if it fails, it should give us that, well, you have inserted some invalid integers or invalid values. So you can just put a simple message like invalid values or invalid value, okay? Now let's try to run it and see what changes. Now I wrote here, let me write here What's going on here? It should work. I don't know what's wrong with this. But anyway, it should work. It should give the message invalid value. But I don't know what's going on. It's taking so long to compile. And I think it shouldn't take much of our time, but it's easy like that. You use value error. By the way, you can extend by having several other. I'm interrupting, so once you see this message, it's about to interrupt. Once you run it in your machine, you should be able to just work quite fine. Let me copy my program again. I want to modify it to something else. Let me modify it to something else. Now I want to change it to something different. Let me write what I want to do. Now we wanna let me say, what if we change our code the following code and supply age as 0. I just want to do something tricky here. Now age, okay, we are getting it an input, and then we change it or we convert it to integer, and then we print that age, but we don't print it at this point. We want to add something here. We want to get the income of this person and say, let's say the income is 200,000. Okay, and well, we want to get the risk of this person. We calculate the risk of a person by getting the income and comparing with the age. So we take the income, we divide by the age. We can say if someone is high risk, well, remember this is coming from one of our examples that I've given you in some previous videos. Okay, so we first capture the value error. If someone enters invalid, age, we could say, well, that's invalid. But we need to get some more exceptions, like dividing by 0, because if we put 0 here, any number divided by 0, computers actually don't really compile. So you need to expect that. So we call it a 0 division error. 0 division error, right? What should we do for a 0 division error? We're going to print a message by saying age cannot be 0. Age, the income could be 0, and we have the income already, so cannot be 0 as well. Okay. Let's try to run, but anyway, it was going into errors. I don't know if it will run at this point. And let me say the age is 56. Let me just put in correct values and see what comes out. Again, it is running into a problem that I have no idea what it is. This is frustrating. But anyway, you can try it at your own and you can see it's working. But anyway, if you supply age as 0, it should be able to capture this that error and say and give this message down here. All right, so you can try it at your own time, and then you tell me what you get. Okay, so let me, for a cleaner code, let me just comment out some of this. Anyway, let me just leave it this way. Okay, you try it, and when we are meeting in the weekly meetings, we can raise a concern if you're also going into this very same error. Probably the kernel needs to be stopped and restarted again. Let me restart the kernel so we won't run into other problems. Yes. Okay, so let's proceed with comments. Comment is, for most of you have an idea what a comment is. It's for the adding notes. You just want to attach a note or a comment to your program. For example, you want to remind yourself about a certain block of code that can be removed or can be added from your script, or you want to communicate with other programmers who will be or who might use your code and etc. We have been using comments. You remember, once you put a hash in Python, you are talking about a comment. Okay, so suppose you have a simple program like this. You want to say sky is blue, right? So what kind of a comment could you write here? In most cases, it's obvious. You don't need me to put a comment. Why? Because it's obvious. The sky is blue. Anyone can interpret what you're saying here. But we may add a comment saying, well, we want to explain probably the color of a given object. Probably the object could change. We're talking about a sky. We could be talking about a house, a building. But if you say we want to explain the color of a sky, that's too obvious. We know it. You're talking about a sky. If someone changes the sky to a house, then this comment becomes obsolete. So it's useless. So you need to be quite kind of. You don't really need to say exactly what it is. Someone can just guess from seeing. So for good practice, let me just put this comment here. For good practice, whenever you're writing comment, don't explain the obvious. For example, this case, this wasn't really necessary. But then if you want to, but wasn't really necessary. So don't explain the obvious. It's not necessary to explain everything, right? For example, using my example here, or let me just give you another example of calculating a function. Our square function that we wrote it earlier, right? You see someone has given comments for something simple like this, right? And n, and then they say n, or let me just go say return n times n, right? And then you see an awkward comment down here saying, wow, this function calculates a square root of a number. So this is awkward because it's obvious when someone def square of n, they know this is just a square root of a number. So then you don't really need to say anything. So my last remark about comments is use comments to explain. Use comments to explain the whys and the hows, but not what. Okay. Remember to have this. Whenever you're writing comments in your program, remember to explain why or how, but not what. For example, you're saying this is what. You're saying what is it? A function that calculates, but that's obvious, right? But how or why, here it could make sense. Why? Because you want to just say. But anyway, this is not a very good example of a comment because it's also quite obvious. Okay. All right. thought of talking about recursive function. I didn't want to talk about it because most students find it difficult to understand the concept of recursive function, and provided our the nature of our course, we just want to grab the best concepts in Python programming so we can work with some image data. Okay, but I thought it was necessary because you never know, you may come across some recursive functions in which you define a function that calls itself. You see, you have a function for square that can call a square function. So it is called recursive. It is repeating. And the common examples of recursive functions you find in factorial or in the Fibonacci series. For the factorial, I think for some of you can remember. Let me give you the function, the factorial of a number. Now this goes to mathematics. For some of you who hate mathematics, that could be tricky, but let me just try to explain in a simple way as possible. Remember, for example, if you want to get the function with the factorial of 5, how do you get it? Remember, we used to write 5 times 4 factorial. Is it? And then you can reduce it, or you can simplify it by saying 4 factorial is also can be simplified. So you can say 5 times 4 times 3 factorial, right? And this also can be simplified further by saying it is 5 times 4 times 3 times 2, times 2 factorial, right? And again, this can be simplified further into 5 times 4 times 3 times 2 times 1 factorial, right? But remember, 1 factorial is 1. So this is equal to saying, let me copy this. This is equal to saying something like this. Now we can easily say, well, 5 times 4, that's 20, times 3, that is 60, times 2, that's 120, times 1, that's 120. So you can get the answer is 120. Now the point is, you have a number, but again, you call a factorial of 4. So whenever you're defining your function for factorial, remember to be calling again a factorial, right? What I mean is, let's define a function called factorial. A function called factorial, like that, of a number n, right? Now, if n, which is a number, is 1, right? It should return 1 because a number, a factorial of 1 is 1. I don't know if you're getting what I'm saying. So if n equals to 1, it should return what? It should return 1. I hope you're together. That means if the number, let's say here it was 5, that is our n, right? If it is 5, because now it will keep on testing. If n goes to 1, it should return 1. S, what should it do? If it's not 5, if it's not 1, what should it do? It should return n times a factorial of a number which is less than itself, times a factorial of a number n minus 1. What I mean is, right, n for this case is 5, right, which we put it here, times the factorial of a number which is n here, minus 1, which is 4. So that's what this is saying. So you're calling a factorial. We had a factorial here, which is of 5, for instance, for this case. But for next time, whenever it's trying to calculate, it will take that number, which is 5, times the factorial of a number that's previous. That's, for this case, it is 4. So you can see it is just doing something like that. And that's the end of our recursive function. A function that is calling itself, it is calling a factorial while we are defining a factorial. That may be tricky, but it is just as simple as that. Now let's think of, let's assume we want to calculate the factorial of that number. Let me put n is equal to 5. I will change that number anyway and say I want to print, let me use the formatted string. I want to print the factorial of n, which is 5 for this case, is, now I'm calling my function here, but remember we are in a formatted string, so we use this one. Okay, so we call our factorial, okay, of that number, which is n. Okay, let's see what comes out. Oh, there's an error. I'm assigning instead of saying is equal. What's wrong with me? Okay, let me run again. Well, the factorial of why is this not F? The factorial of 5 is 120, which is equals to our answer here. So you can change this number to any number smaller or bigger than that, and then you can see it's saying 24. You can save the factorial of 10. But remember, avoid testing with largest number because it may take time to calculate, because it involves a lot of computations going through counting and decoding and recursiving or recursing several times, right? So that's a recursive function. You might find it useful whenever you're working with your data, but I'm not sure anyway. I do not have an example where you can use a recursive function for our case, but just expect to have or to come across such a thing. The other thing is that Fibonacci series, which I'm not going to talk about it. I don't think if it's necessary for the moment, but the recursive function, you might find it useful, you might not find it useful in your case. But if you were doing for an exam, recursive function is also important. So let me wind up with file handling, because you're going to deal with images. You should expect to meet or to deal with or to work with files. And I won't use images. I will use just a text file. For your case, you might meet a lot of image files or CSV files. So you should expect those two. I'll use TXT or text file as a representative of those kind of files. So there's a lot of methods that you can use with in file handling, including open, read, write, append. They are obvious. Opening means you want to open that file. Reading means just want to read it. Writing, you want to add some content into it. And appending, you want to not just add, you adding at the end of the given file. Writing erases everything and starts afresh. And then closing, you want to exit your file. So how do we go about it? You can define your file like that. You want to open it. I have created a file which is, I named it as yes.txt. It is here anyway, yes.txt. Okay, I can even open it up to see the content. There was something here, blah, 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 right? So that's the content. You want to open it or you want to play around with it. So you use this command, and what do you want to open it for? You want to open it for reading. So you specify the purpose, or you want to open it for writing. You want to open it for appending. So for writing, you write W. For appending, you write A. Okay. So let me see what comes out. Let me print the name of the file. So I could say file.name. And what mode is it in? We could say file.mode, right? Okay. Okay, let me print. Sorry, I forgot to writing print. What will we get anyway? Let me comment out this first. Let me start with file name. Will it say our file name? It's complaining about an error. And what is the error? No such file, yes.txt. This is tricky. What's the name of our file? Yes.txt. What did I write here? I write text. It was supposed to be txt. Okay, so it is yes.txt. What is the mode? R, that is read. Okay, that is the simplest thing you can do about it. Let me add another cell and explain some more concepts about it. Now, it is whenever you write using this kind of approach, this mode, remember to close whenever you are done with it. So you should say file.close. Okay, but close is a method, so remember to put it in quotes. Okay, you won't see anything whenever you write file.close, but it will have closed it internally. It doesn't need to show you. But I know we don't really need use this kind of approach. File is equal to open. We use what we call context manager. So let me say opening with context manager. And what does context manager mean here? I'm sure for some of you have come across with the word with open. So you don't say file is equal to open. So you could say with open, what are we opening? Yes.txt, comma, the mode that you want to open it in, you just want to read. And now, instead of saying file is equal to, we say as file. So you see, we have changed a little bit the structure where our variable file is now at the end instead of putting it this way. And you'll see this is the most common way of opening files in Python. Instead of file is equal to open, no, we say with opening blah 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 as this. Okay, as file. So what do we want to do? We want to display the content, or we want to read the content. So let me say file, let me just content. File contents is equal to file.read. We use our method for reading the file, okay? And we want to print the content on the screen. Print file content, okay? If I run this, I expect the content to be displayed here, something like this, okay? Now, suppose I just want to read a few characters. I don't want to read the whole file. Let me add another cell, and let me say, suppose I just want a few characters or lines and stuff. Let me paste this and say, wow, I don't want everything. I just want, a few characters. Now, instead of reading everything, file.read, I specify a number of characters. Let me say 20 characters. Whenever I say 20, I mean characters. Okay. So what will be the output? Let me try to run and see. There was something. You see? Whenever you count these are actually 20 characters, including space. Okay. So for some people, to be just safe on the other side, they just write the word end with nothing. It is actually a safer way, but it's something the same. What if I write 50 characters? What will be the output? You see? And you can change the number of characters you want to display. Okay. So that's it. And let me keep on giving you a little bit more content about reading characters or rhymes. And now I wanna change a little bit. Instead of just read, let me say, if you're using PyCharm, if you press dot, it will just suggest the functions that are associated with file manager. But if you're using Jupyter Hub or Jupyter Lab or Jupyter whatever, I think you could use tab. You press on the tab, you can see there are several methods that you can use. For example, I was using read. There's readable, there's read all, there is read into. I want to use the read line. This one. Okay. When I use the read line, well, I think read line or read lines. Let me get all of them, because let me test with the read line and see what do I get. You know, put this read line. What do I get? It's just getting the first line. What if I say read lines? I don't know. Getting everything together into kind of a list. You see those square brackets? They have put everything together into it. So there are several ways in which you can work with this. Okay. And another way you can iterate through. You can use the for loop to iterate through. Let me again copy this. Let me just write with open. What are we opening? Yes, txt as read. Sorry, as file. We want to iterate through our lines. So for each line in our file, what should we do? We want to print that line. We want to print that line. You can do that, and then you can end with whenever you see there's a gap. What will be the output? So it is reading through the lines. So this is also another way to do the same thing as I've done up there before specifying the number of characters that we want to. But it's also doing the same thing, right? You can even copy the content and paste it to some other file. Okay. So how do you do that? You can, let me add another cell and say with open, what do we want to open? Yes, txt. I've got to put this. And we wanna write to a file. So you're writing in a we're opening it in a W mode, in a write mode. We change the, let me just write file. So file dot write, I want to come up with my now I will mess up things here. Well, here we wanna write some content. Let me change the name. I'm creating a new text file here. Let me call it yes2.txt. So what content? What's the first line? So my first line should be this is different content. Okay. And maybe I have two lines. At the second line, and you can have several of them, right? And my second my second line text. Okay, so once I run this, a new file called YEESI100 will be created. When you look here, there's just YEESI1. I was trying to exercise and I created this. So I want to create YEESI2. So with this content, with 2 lines, if I run, you see there's nothing displayed here. But when you come here, you see there's YEESI2.txt. And when you open this, you can find this is different content, my second line, blah, 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 but they are all in the same line. So once you're exercising, remember to create content that can be displayed in multiple lines. Okay. So that's it from me. And I think this video concludes my part of Python discussion. My colleague Mkwazi will take you through the second part, which is mostly from here: data structures and algorithms, math threading, concepts of object-oriented programming, and so forth. I hope the class was exciting in some way. And I hope the concepts of data structures, the concepts of object-oriented programming, and several other issues, especially packages that are used in machine vision, will be exciting for you. And for this part, I think it could be important. It is expected that it's important because it builds the foundation for you to work with images for machine vision. So I hope we are all together. And if you have queries, if we don't meet in the weekly meetings, please drop your comment or your query on my SUA email, which is josephmasamaki@sua.ac.tz. Thank you and have a wonderful time and a wonderful session as you go along. Thank you so much.